Now, the environment that I use for programming is actually a basic text editor and a compiler. Now, talking about the compiler, there are many compilers that you can use, but one of them is MingV, which is minified something. I don't remember the whole thing here, but this is basically a port from Unix-based systems, which is a compiler on its own, and this is basically ported to Windows. Now, in order to install this one, you have to go to, let me find it, go to Google, just write MingV. There's a 64-bit one, but it doesn't really matter. You can use 32 bits. This is the Minimalist GNU for Windows. You download this and it'll just pop up a window. Once you've installed that, just confirm, next, all that usual stuff. And then you just select basic installation and it'll just do what you want. Just install it, continue. And once you have done that, you will have a compiler available. You might also have installed Visual Studio 2000, I don't know what, maybe 2020 or something like that. The Microsoft compiler can also be used, but I highly discourage that because it has a different compilation process. You have to use Visual Studio for it. But in this course, I'll be asking you just for .c files, for example, or .header files, and you have to submit that. But in Visual Studio, you will have a whole project for it, so it will be a harder task for you. So I would recommend you to install MingV, and if you have some problems, and if someone in the Discord channel has already done it, they might help you out. You might ask for help there. But it's a basic installation. Once you have done that, you'll have a folder, which is in my case, CMingV here. And of course, you can just go to the bin directory and then find the compiler, which is GCC in our case. So I will be using this gcc.exe, but it doesn't really make sense to just come to this directory and execute it because my code will be somewhere else and then the compiler is here. In order to prevent that, once you have installed MingV, what you can do is you can just take this path of MingV and go to system properties, I guess. System path. Yeah, edit the system environment variables. If you click this, you'll come to this GUI here, and then environment variables, which is this button here. Click here, find the path variable, edit. I have quite some stuff here. Is this the system path, by the way? Let me see. I guess it is. So good. Path, edit, and then a new one, and then add MingV. So let me see. So the system path, is this the path, I guess? Okay, this is the path, not the one here, not the user, the system variables. Okay, that was my problem. So we look for the system variables, path, and edit it. And you can see that I have lots of stuff in here. But here we go. CMingV bin. So that should be in your system variables in the path variable. If that's the case, and once you have done that, if you do this for the first time, what you can do is you can restart your computer, or you can go to here, which is a fake restart, and then find the Windows Explorer, which is hopefully going to show up here. Where is it? There we go. You can also go ahead and restart this Windows Explorer here. This is a fake restart, sort of. Or if you don't want to bother, you can just reboot your computer. Once you have done that, you will be ready to compile stuff. Now, in order to compile or use the compiler, we can use cmd, just the command prompt here, or I have already added to the taskbar, but Usually I enter CMD. Now I can use GCC. As you can see, this is the output. It says fatal error, no input files compilation terminated. So this means that the compiler is ready. You can use the compiler, but you didn't provide any input files. So it asks you for files to compile. So we'll be using this in a minute. But up to this point, let me sum it up for you. You have to go to the website, download MingV, install it, and once you have done that, you will have MingV here. If you don't change anything, it will be this exact path here, C MingV bin. You have to copy this, go to the environment variables. You can also edit the system environment variables, this here, and then from the system variables, go to path, and then edit, then add a new one and add MingV to it. Then reboot your computer and you are almost ready. So this is one thing that that I use. And another thing could be just a plain code editor, like Notepad++, for example. You can just go ahead and write some files. For example, let me show you an example. There we go. Once you save it, let's go to desktop and change, of course, the type here. Let's say test.c. You can see that Notepad++ assists you with the coloring, the styling here. So this is our first C code. And now I have opened up a command prompt. And in this command prompt, I can see that I'm in the users folder and in my personal folder here. If I do something like dir, it will give me the directories. And I have to use cd, which stands for change directory. And I'm going to go to, I guess, desktop here. So in my case, I have to go to OneDrive because I'm using OneDrive and then desktop here. So I'm basically here. And we can see that I'm here because we have all the folders here that are listed in here. And there's this test.c. So if you use Windows like me, you can just go ahead and if you have OneDrive integration, your desktop might be under OneDrive. If not, it could be your username desktop. Or sometimes is it available here? No. Oh, I can show you another quick way of doing this, which is much easier. Use your file explorer here, come to desktop, and go to this address bar and type in CMD and enter. It will open it up in this directory. So if it's easier, you might also go ahead and use this. So I've just basically used my file explorer, clicked here. This is the address bar, type in commands, enter it, and you have a console or a command prompt that is in that directory. So now I'm in the right directory. I can use test, and if I hit tab, it will auto-complete it, and I get this test C. Now I can just say GCC test C, and it compiles, and we have a new file here. So if I use dir, you can see that it is called a.exe. Now, if I run a or a.exe, just enter a, nothing happens because the code does nothing, but I have written a basic code, compiled it, and I ran the program. So that's basically an environment that we can use. I will still use GCC here, but a much cleaner way is actually using something else. My recommendation would be, let me just delete this too. My recommendation would be to use Visual Studio Code, which is basically which is this here. Now, this is also something like Notepad++, but it has the capabilities of using some extensions. For example, we have the ability to just pull this bar here, and then you have basically the CMD, the command prompt available for you, which is in this same directory here. So if I hit dir, I will see that there's week1.pdf. So you don't really have to bother with this command CMD typing into this address bar, etc. So you can work with projects here. So you can see that you will have CMD and then also maybe PDFs. So if I have a code, test.c, I can see it. If I hit dir, you can see test.c is here. And what I can do is I can just, again, write the code. std, come on. It also gives you some programming recommendations, some code completion. So all that stuff is quite neat. You can just go ahead and use it. I like to use Visual Studio Code for certain reasons. And in order to do that, you have to install extensions. For example, you can see we have Intellisense, which is a Microsoft thing as far as I remember, but it gives you some code assisting capabilities. You can also set the compiler up here, but I'm not going to bother with that because it's not really that necessary. In a moment, I'll show you why. There are also some themes, so you get nice coloring here. But actually, the C++ Intellisense part here is the most important one you can use, in my opinion. So MSVC, CLang are the compilers that are present, but we use GCC, so you can see it's also actually usable here. But I'm not going to go into detail. Now, if you are in a different operating system, then the only thing that you have to look for is to install GCC, because GCC is already Unix. And if you are using Ubuntu, macOS, all those operating systems would have probably are shipped probably with a GCC already. So you might have GCC installed. In case of Ubuntu, as far as I remember, it is already integral to it. If not, you can just use apt install or apt get install if you're old school like me, and then build essentials, something like that, and it will just download the GCC compiler or G++ compiler that you can use. In macOS, you might use Brew or something like that, but just a quick Google should help you out and you would find it. So in my case, I will be using the Visual Studio Code environment here, and just to use CMD integrated into this window, and I will have my code here, and I also have some PDFs because I have already prepared tasks for you. So it is kind of nice to use this. Now, let's say we have already something written down and we want to compile. You can go ahead and use gcc test.c, it will compile, and you will get a.exe, which you cannot preview, of course, and then you can run a or a.exe. Now, first of all, the first thing that bothers me is that the name is a.exe, which is a random name. So I want to get rid of that for starters. So what I can do is I can provide -o, which is an output argument, and give it a name, for example, test. So GCC, and then all the files that you want to compile are listed here. Test.c is C. If anything else, that should also be placed here. And then -o for output, and give it a name test. If I enter this, what I get is basically test.exe now. I have test.exe. So just let us delete a.exe. Now you can see that we have a exe that has the same name. Now, of course, at some point, you might have multiple files and you want to repeat this. Of course, you can use this here, or for Windows, what you can do is you can just create a file, let's say compile.bat, and in this, you can just provide it the necessary steps, like GCC, and then you can hit compile. Before I do that, let me just get rid of this. So if you hit compile, you can see that it's pasted in this command. So it's basically automated. You're just going to call compile, and it'll compile and create the file for you. If you don't want to see what the steps are, you can just put an echo off and then compile. You can see now there's no extra step. If I don't do this, if I compile, you can see the additional step is provided, or it is documented or echoed in this case. Compile, and there we go. You can also do CLS, which stands for clear screen, by the way. So if you do this, it clears the screen and then compiles, and then you have test.exe. If you want to also run it, you can just go ahead and do this, assuming that it is called test.exe. So compile. There we go. Of course, the code does nothing, therefore we cannot see if it's running or not, but we'll solve that in a minute. Now, in Ubuntu and in Unix systems, this would be an SH file, and it's basically the same. You just put in this one here and invoke it with bash, or just run it as you can do it. You can look it up, but it's basically the same. So, yeah, there are some other integrated development environments, IDEs, but I would say it's not really that you don't really have to use IDEs, because they will have some additional features, some crowded graphical user interfaces. All you need is to keep track of your folder, your terminal, and the code itself, and nothing else. So Visual Studio Code is quite neat, and I can show you, for example, something. This is my folder where I generate also the PDFs. I have a compile bat file that creates the PDF. I have all the C code here. All those C codes are integrated into this PDF automatically. So I can do pretty much anything I want using Visual Studio Code. Here we have, again, compiler, the name, and then the output. So I have multiple lines of this. So it will compile them individually, create the exe files, and I can also test them. So using Visual Studio Code is a neat idea, if you ask me, but feel free to use other stuff, but I'd recommend Visual Studio Code and MingV on its own. So do you have any questions? All right.
Ben derse girdim de hangi uygulama bu?
Visual Studio Code ve MingV. Zaten hani bu kısımlar kayıt alındı. Tekrar bakabilirsin. Ama Visual Studio Code kurdum. Visual Studio Code'da da C++ Intellisense eklentisini kurdum. Bunu kurduktan sonrası aslında tamamen compiler varsa eğer compiler'ı kullanabiliyoruz. Yani ben zaten dışarıdan da compiler'ı kullanabiliyorum. GCC diyorum. Burada da çalışıyor. Burada zaten entegre bir terminal var. O özellik. Onun haricinde ekstra bir şey yok aslında. Bu Notepad'le de yapılabilir. Yani kullanmak isterseniz şu şekilde bir Notepad'le de kod yazıp kaydedip sonra da gidip CMD'yi de açıp bu ikisini birlikte kullanabilirsiniz. Bu ikisini birleştiren bir de PDF göstermeyi destekleyen Visual Studio Code'u kullanıyorum ben. Zaten Discord tarafında bunlardan problem olduğu zaman soru sorup zaten cevabını da alabilirsiniz diye düşünüyorum.
Hocam bir şey sorabilir miyim? Bu
Tabii ki.
GCC'nin basic'ini kursak yeterli olur mu, yoksa o package'i kurmak gerekiyor mu?
Şöyle sadece hepsini kaldırıp bir tanesini değil de default açtığınızda gelen ekrandakileri kurmanız yeterli. Onun haricinde ekstra bir şey eklemeye gerek yok tabii ki. Ama zaten o MingV'nin kurucusunu indirdiğinizde otomatik gelen şeyleri kullanmanız yeterli oluyor.
Tamam.
Hocam ders Türkçe ile devam edecek miyiz yoksa İngilizce mi?
İngilizce takıldığınız veya tekrar etmemi istediğiniz kısımları Türkçe olarak şey yapabilirsiniz. Çünkü yabancı öğrencilerimiz var. Dolayısıyla mecburen İngilizce işlemek durumundayız. Ama anlamadığınız veya tekrar anlattırmak istediğiniz kısımlarda araya girip hocam burayı bir de Türkçe tekrar edebilir misiniz derseniz ben Türkçe'de tekrar ederim. Özellikle temel konularda sormanız gerekebilir tabii. Evet, var mı başka sorumuz?
Hocam eko olsun kısmından tamamlamasını söyleyebiliriz. Eko olsun ne anlamı geldi?
Tam sesi alamadım ama. Ha, echo off'un ne olduğunu tekrar edebilirim. Şöyle bakıyorum. Okay. There was a question. I downloaded Dev C++. Would it be a problem? It would not be a problem. Just remember that you would upload .c files, for example, and I most probably will ask for individual files. So if you just provide me the code itself, not the project, that's all right. You can just use whatever you want. Dev C++ kullanabilirsiniz ama bana .c dosyaları, zaten ben onu belirteceğim muhtemelen ama bana .c dosyaları göndereceksiniz, proje göndermeyeceksiniz, ona dikkat etmeniz yeterli. Echo off kısmına gelirsek, az önce aslında kapatıp tekrar gösterdim. Compile dediğinizde, bakın burada hemen şu alt satırda, 3. satırdaki kodu tekrar buraya yapıştırıyor, çalıştırıyor. Mesela bir sonrasında da test exe'yi çalıştırdığını söylüyor. Ondan sonra bitiyor. Yani şu alttakileri tek tek çalıştırıyor ve bunları yazdığını görüyorsunuz. Eğer bunları yazmasın, ben zaten biliyorum derseniz benim gibi sadece compile dediğinizde o adımları görmeyeceksiniz. Sadece sonucu verecek. Bakın adımlar yok. Echo sadece buraya da yazayım mı yaptığım adımları. O çok önemli değil. Bu bat dosyası otomatik çalıştırmak için echo off yazarsanız şu alttakiler gözükmesini sadece yapsın demek için. Evet. Sanırım başka soru yok. Devam edebiliriz o zaman. Now, let me get rid of this test.exe for a moment. So, now this week we will have 4 basic tasks, and I will be showing you how to code them, or I will also try to introduce you to the C programming language. Now, why do we need a compiler? What are we actually doing here? Let me try to explain it to you. First of all, it's actually a cliche, but I have to tell you that the computers work with ones and zeros. So that's the basic thing here. But how does it work with 1 and zeros? Let me just give you a quick recap. Let's say I want to add 2 numbers, and one of them is just 1. The other one is also 1. So 1 plus 1, basically. The computer itself has a central processing unit, which has an arithmetic logic unit, which is basically, we have a CPU, which is a CPU, the silicon thing that we all see in our phones, in our devices. So this is the CPU. In the CPU, we have something called ALU. Now, nowadays, like Apple Silicon, for example, has also other stuff in it. For example, a neural engine. So it has a neural engine. It has a GPU, graphical processing unit, etc. But we're interested in the most basic one, which is the arithmetic logic unit. And in this arithmetic logic unit, as the name implies, we have arithmetic available. The CPU, in its most simplest form, has 2 inputs and an additional input. Of course, there are many more connections to it, but we are interested in 2 inputs and an additional input here. One of them is operand 1 for arithmetic operations. We have operand 1, operand 2, and the operation itself. Here, in our case, 1 is operand 1, the other one is operand 2, and this plus here is actually the operation. So I want to sum 2 numbers, therefore I need 2 numbers and a sum. And then we'll also have an output, which will basically be the result of this arithmetic operation, which would be 2, and which would look in binary like this. So the logic behind this is not the scope of our course, because you have to know the two-base system, and then how to add, subtract, divide, multiply in that two-base. But other than that, the CPU can do this, and you can give it the operation, the operands, and it will do it. Now, during programming, or the most basic programming actually stems from this arithmetic. If we can do basic arithmetic, we can do more complex things. For example, I can add and add and add. And how many did I add here? For example, in this case, we have added 5 times. So this will be the operation 1 times 5. If I can do this, I can also do basically division. And then I can start to implement more complex mathematical operations like power or like the sine function, etc. So it's basically starting from a calculator. We have operands, operations, or more complex operations based on the basic operations, and we have a calculator. Our computer in the programming course will act like a calculator, but with more memory and with a memory usage that is more complex than a calculator. If you view it like this, you'll see that you have a very, very basic calculator that you are trying to use, because for all the graphical user interface programming stuff, for all the complex software, you need much more. But we are interested in the most basic form because C is mostly used in low-level hardware. You will have a hardware, a board, an electronic board, and you can implement your code in order to accomplish a certain task. So therefore, we are learning C. If you're, for example, interested in much complex programming, C would not be your choice because C is aimed for hardware. It is a low-level language because you have to think like a computer, not like a human. You cannot give it a command that is for human understanding. You have to understand the computer, deal with it, and tell the computer what you want to do. This whole programming thing will be this. So now what does it have to do with memory and all these operations? Well, we write some code in here, and this code will be compiled, so it will be transformed into a language that can be understood from the computer or by the computer. Now, this is a semi-human, semi-machine language that we will be learning in this semester, because there are some parts where I get the idea. For example, main. This seems to be a mathematical notation, so this is a function, perhaps, and it is a main function. That's good. But why do I have return 0? What does int mean? I don't know at this point. So this is the semi-human machine thing that I'm talking about. There are some aspects or names that can be understood by a human, but we need more knowledge. And here is also something included, which seems like a piece of code, for example, in this case, that is included in here. Why? We'll see. But here the name implies that it is STD stands for standard, IO, so input, output. So we have the standard input, output thing. We don't really have to have this. We can just get rid of it. And this will also compile. Let's basically start with that. So let me just comment it out. Now, this is called a comment. If you use slashes, 2 slashes, this is a comment. There's also another one that we can use. Let me show you that one. Slash, asterisk, and asterisk slash. So everything between this portion here is basically a command. It's a multi-line command, but it's not really that important because nowadays editors help us out. So what we can do is we can just choose all of them, control. Since I'm using Turkish, I have to click this here. I don't know what the English or American keyboard version is, but you can look it up. It has some shortcuts. This converts it into a comment. And as far as I remember, if I do it once, it turns it into a comment. If I do it again, it'll undo it. So these are basically Visual Studio Code dependent. You can look it up in the settings. Now, this will also compile, hopefully. let's see. It did, and it ran. So I don't really have to include this part, but I have to have this int main and then this return 0 for whatever reason. And I'm going to tell the computer in between these two lines what I really want to do. Now, why do I have such a notation? First of all, we are using operating systems. On certain low-level hardware, we might skip that part. There might be no operating system at all. In that case, you handle it on your own. Therefore, you don't really have this main function thing there. But since we are using Windows, since we are on a personal computer, we have to have an entry point, a starting point. And actually, our code lives within the operating system. So it needs permissions to access the computer's RAM. It needs to have a starting point. It needs to communicate with the operating system. And 0 stands for OK here. So it's a code for OK. And if you return OK, so basically what we do is return OK, we tell the operating system that nothing bad happened. So it's like a HTTP client, like a web page. It returns some codes. You might have seen 404, page not found, 400, internal error, stuff like that. But otherwise, it has the content itself. So this is basically, again, the same mentality here. You return OK to the operating system to tell the operating system that nothing bad happened. It didn't crash. And it notifies us that it didn't crash. So it's not really that important. But it expects us to return something. This is our main function. We use this mathematical notation. If we have these brackets here, it means that we will pass in something. But in this case, it's empty. We didn't pass in. It's like sign, but without anything in it, or F. So it's just calling it. These curly brackets are basically code blocks. So in this, we have block of codes. And well, what really happens here is that, for example, here, it will generate a machine code that returns 0, that doesn't do anything. So it will be a very basic thing. And exe files are actually machine code. We cannot really see here, but it is just plain machine code. And the operating system can run it. And that's the thing. We are trying to write code that does specific stuff, but lives in an operating system. And we want to double click it or just invoke it. And we want to see the results. In certain cases, we want to communicate with it too. We'll come to that. But this is the basic structure that we will use most of the time. And there's also something like int argc. Let me see if it just int arg. Nah, doesn't do it. Okay. Int argc char pointer argv, something like that. You will see in some books or in on some web pages, you will see something like this. Let me explain you what it really is. This arg here stands for argument. So therefore, these are arguments. And then this C and int here stands for argument count. So how many arguments are provided? And then we have argument variables. So this is to call test.exe and then let's say call it like this. So this is the program name, but these are the arguments. In this case, argument count should be 2 or 3 if it counts test.exe. I don't really remember. We'll see. And then the variables are these individual parts here, test.exe, and my name and my surname in this case. So sometimes we want to give some additional input to the exe file. This is possible, but most of the time you just double click it because you're using a Windows computer. But if you are a Unix computer user, you might get it easier because these are more common there. Well, this is nothing important. You can just skip it. You can also do something like this. This is also a usage like void, and then just compile. This is also possible. These are variations. If you see them like this, don't be scared. It's just something that we will be learning on the go. Now, let's do something meaningful in order to see that our code actually does something. So our first task is to just write a hello world.c program. So let's do that. For example, first of all, let me get rid of this. And yeah, let me just delete this and come in here and say hello world.c. Its output name should also be hello world, and it should run hello world. By the way, you don't really have to put in the exe. You can just do it like this. Let me rename it to hello world.c, and there we go. Now the missing thing is that we have to have a function or something, a piece of code that writes out to the console. But because what I want to do is, for example, I want to see something like this, hello world, and then exclamation, and that's it. The program should output this to the console. Therefore, I need to communicate with the environment that I'm in. And remember that stdio stands for standard input output. This is standard input output, basically. It is the terminal. Usually what you expect is graphical user interface, but in our lecture, it will be the terminal itself. So we will be using the CMD. We will be seen as a hacker, for example, from people that don't know any coding. But yeah, we will be using the terminal for input and output, as you would use actually the buttons on a calculator and the screen of the calculator. Now, stdio.h is a file that has stuff in it. Let me show you what it actually has. You can just directly Google it. You can also find it on your file system, but it will be much easier for me to Google it, of course. And yeah, the documentation of stdio would be a good idea. Let's see. Standard input output IBM's page. It doesn't really matter. You can just Google anything about C. Hopefully. So it has standard buffered input output. We use it like this, include. The description is here. We have some local variables. And then these are all the available functions or pieces of code that are already there that we can use. For example, clear error, something like that, flush, put as, read, reopen. So it is a input-output thing, a library that is already there that we can use. One of them is Scanf that we will use, and another one is Printf, because it will print to the console, print or scan from the console. There are also other stuff that will be useful in the upcoming weeks, but most of the time we will be using Printf and Scanf. These are functions available, and they look also like the int main function, as you can see. It has int, it has a name, brackets, and that's it here. It's kind of a protocol that says it has a certain return type, it has a certain argument, and it has a name. So you can look it up and see how to use it and remember how to use it or learn how to use it. You can just look up f.c, for example, or let me just go for printf. Here, you can just click on it and you'll see the documentation. It will print formatted output. And you can use it like const chart, star, format, comma, etc. This doesn't show you that much in this case, and you might be wondering what all the things are, but you will be up there. You will understand it in the upcoming weeks. Now, there are lots of documentations about this, but the part that we will care is actually the keywords that are available in C. Now, let me list some keywords here. Int, float, double, what else? char. What else do we have? Bool. So these are some keywords. We have also return. In this case, include is also a keyword. So these are keywords. Now include is self-explanatory because it just copies the internals of stdio.h. So this is a file, and all that's in that file will be included before we code anything. So it will be available to use here. So that's one. And we use a hash sign here in order to indicate that this is an inclusion, and we will use it like that. You cannot use include on its own. As you can see, it doesn't even highlight it because it needs a hash. So this is hash include, and then we give it the file. If it's a global file, we will use this. If it's a local file, we will use double quotes. But it's not really important at the moment. So this includes stuff. In that stuff, we will have printf in our case. So this is now available because we've included it. Now, int, float, double, char, bool are actually variables. Now, the computer has a certain amount of RAM, which is random access memory. So this is basically memory. And in some calculators, some scientific ones, as far as I remember, they have memory. So you do a certain operation like 2 times 2 plus 2. You have to first calculate this part, put it into memory, and add 2 to the memory. So this is kind of the thing that we might need in our programs. We need memory. And in order to use them, we need to tell the computer or the operating system, in this case, what type of usage this memory will have and how we will access it later. So in order to do that, we have to choose one of the types here and then give it a name and then end it with a semicolon. In C, pieces of lines will end in semicolons. So this is basically in order to the converter that'll convert this piece of code into machine code looks for semicolons. It'll just stop at a semicolon, take it as a line, the next one, and then extracts all the codes, convert them into something else, and then create your exe file. So therefore, it is important to not forget these semicolons if you terminate a piece of code. For example, return 0 is a command. Semicolon is needed because this is the whole command. Now, here, we will choose one type, let's say int, and then give it a name, like variable 1, for example, and semicolon, and that's basically it. So this is our first code where we have allocated some memory. We have used up memory. Well, we just defined, or we just promised that we will use, but we didn't, but you get the idea. Now, what does int, float, double, char, bool stand for? Now, int is actually integer, the abbreviation of integer. Float is floating point number. And double is a double precision floating point number. Char stands for character. Bool stands for true or false, Boolean, or bool in some languages. And we have return, which basically returns something. Now, since I have chosen int as the keyword here, as the type, this is basically an integer. It could be 0, it could be -1, it could be 255, it could be something. But it should have an integer. It defines an integer. And in my case, since I'm using a 32-bit compiler, I can use 32-bit integers. So this would be, if I'm not wrong, this would be 2 to the power of 31, and then 2 to the power of 31, something in this range. We can look it up. But I can define huge integer values by using int. Now, this float and double is actually an IEEE definition. It has an IEEE definition. You can look it up, or we can talk about it later. But for now, it is important to know that there is a floating point number, like pi, 3.14. You can define this by using float var2 equals 3.14. This would be 3 if we would use integer for pi, it would be 3. But if we use floating numbers, it would be 3.14. You might ask what the double does here. The range of the precision and the range of that increases as far as I remember. So if I stay here, you can see in double there are that many digits, but actually in float these are not that many digits. So let me see. So you can see the difference in the precision actually. So you can see now this F here, most C programmers miss this, but this F stands for float, and if it's float, it has less precision. Here we have an assignment, but if I get rid of this F, which you can do for starters, you can see that my code editor reminds me that the value on the right is actually a double value, but it is then put into a float variable, which means that it will lose some precision. So this is a conversion here, but if I put in F, it will be no conversion, directly float definition. It's not really that relevant at this moment, but C is such a language that you can optimize almost everything. You might have heard that C is a language that is fast. It can be because you can prevent extra and unnecessary stuff. You can be optimized in this language, but you have to know your hardware or your machine. Well, enough with that. Basically, we have float, we have double, and you can also define bool var 4, which is true. Oh, it's true actually. We'll see. And yeah, and then we have a character. Now, the character is used like this. We will use single quotes, and then we will use the character. This means that this is a character. This is not a variable, because I might have something like this, int a equals 3. The name a here is for a variable, and it has the value 3 in it, which is an integer. But if I would not use single quotes, I would try to assign the value of a to var 5. Which doesn't make sense because I don't want to do that. I want to define the character A, the one that is available on the keyboard. So we have that A key on the keyboard. If you use quotes, it's kind of the key A or key X, whatever. And I want to define that. So you have to use single quotes if you're defining characters. Now, these are the variables, the basic variables that we can use. And we will be talking about them a lot more. Let's actually do something relevant. Let's try to print out a message. For that, I'm going to use printf. And if you use Intellisense, you can see it kind of hints you to something, but in our case, it's not really that useful. Now, single quotes are for characters. And if you have many characters like this, you can use double quotes. And that's basically it. So you're providing it a double quote thing, which is actually, again, 11 characters in this case. So you can see that there's this character type char, but there are 11 of them because this is a 11 character string, basically, or word. But it uses double quotes, and you use printf, and you're good to go. Actually, let's type in hello world exclamation, and that's basically it. This is our first code. If you don't include stdio, let's first do that and see what it really does. So let's compile. So we couldn't compile, and here we have a declaration printf, and then it says printf, and then warning incompatible stuff. And there's a note for us. It says that provide stdio.h or provide the declaration of printf. So what it tries to tell you is that, well, I don't really know what printf is because it's not defined. If you include this, you'll see that the error will vanish. And it is just telling us hello world. Nowadays, the compilers can also maybe include the necessary stuff for you, but you should know your libraries and know your header files. In this case, these are called header files. .h is for header file. You should know them and you should include them wherever you need them. So this is basically the hello world example. We have an include, we have int main, we return 0, and this is basically an integer, and we're returning an integer 0 here. You can see int 0. And we have used printf, and we have provided a multiple characters, which is called a string here. So this is example 1. We can experiment with printf and see what we can do. So let's define, for example, int age. We can go ahead and assign age to, let's say, 20. Now I can also add stuff to age, so age plus 43, for example. I can do this operation here. But what if I want to see what the value is? Because if I do something like this, and let's get rid of printf here, let's compile, you can see nothing happens. So hello world.exe, and nothing happens. Why? Because we have defined or allocated some memory. We have assigned it a certain value. We have added a certain value to that variable or memory, piece of memory, and we return 0. In order to see what the steps are, what the results are, we have to notify the terminal, or we have to print something to the output to see what's really going on. For example, if I want to see the result, you have to use printf. But the problem here is that I cannot directly give like age to printf and try to see what the result is. There's no method that does this. You cannot say, okay, here's the variable, print it to the screen. That's not possible here. For now, you can of course do it on your own. What you have to do is you have to convert this data into a string. What I mean by that is this. There's 20 and then there's this double quote 20. These are not the same. This is text. This is text value, but this is a number. And those are different for printf. Printf can only put those characters on the screen, but it cannot handle different data types like integers, like floats. You have to convert this into compatible data types. In this case, strings or double quote characters. So in order to do that, what you can actually do is you can provide two things. The second one will be age. So there's a way around this. What you can do is you can say, okay, I will give you some data, but before that, let me tell you how you can convert it into a string, a double quote thing. And that's by using double quote. And then since this is an integer, you can do D, which stands for decimal. But you have to tell printf that this is no ordinary D. This is actually %D, which has a special meaning. So there's a table. There's a table like this: integer, float. Again, F actually can also handle double. What else? Actually, C for character, S for string, which is not really a data type, but which is actually double quote something. So we have a table like this, and printf can handle them. So %D, %F for double and float, %C for char, %S for string, can be used in order to combine different types of data, different types of values. For example, if you use %d and then age and compile it, you can see that the output is 20. So it doesn't have this capability. You cannot give it directly, but what you can do is you can tell it to convert it, and you can give as many variables as you want. You can do age plus 1, age plus 10, but you have to copy and paste them. So there are 3 different data types that you have to convert, and those are these 3 things, 20, 21, and 30. Of course, I didn't place any space because it is literally taking age, convert it into a double quote, and add the next one and the next one to it. So it has this interesting looking number here, which is not really the number that I'm after. What I can do is I can just put in spaces, compile it, and you see it will convert it, put a space, convert it, put a space, convert it, and print it. You can also say something like this. So you can combine strings or these double quote characters with integers, floats, doubles, etc. You have to convert it. What you also can do is, let's convert it into a float number, for example, because it will get trickier here. Let's say float and height, something like that. Let's say 12.34 is the height. I'm sorry. Is the height that you want to print. And I can also place in some F if I want to be correct. So we have height. And since there's a table, what I can do is height is %F. So compile. You can see it prints out height, and it is 12.34, and then there are a bunch of zeros, and that's it. So we can actually tell additional parameters to printf. For example, we can do something like this, 3.f. So it uses 3 digits. It has this extra space here, because there's just one space, or let me get rid of this space. You can see there's an extra space, but then there's nothing after the point, the decimation point. If I do something like this, 3.3f, you'll see it uses actually 3 digits here, or it can use at max 3 digits, but it gave me 3 after the decimation point. So if I increase this, like 8, for example, it increases the number of, actually, you can give it the precision. 8 is the precision here. So you can have 8 digits after the point, and even more before that.
Teacher, I have a question. I couldn't understand the difference between float and the double.
Float and double are different data types. Actually, they are the same data type, but they have different precision. Let me show you. I have actually shown it, but let me show you again. So if I define the same number, 34, like this, and if I wait on it, you can see what it looks like in double. So let me give it a more subtle number. Yeah, in that case, it's not working. Let's go back to 34. So you can see how many digits there are in double, but you can see that's not the case for float. That's the only difference here, precision, because this is basically double float. It is a float, but it has double the precision. It's again a float. And it becomes relevant if you are working at NASA, for example. If you will multiply a float number with huge numbers, then the decimation or the precision of that number becomes relevant, because interstellar or intergalactic calculations need higher precisions. And if you use float, you will end up in a different planet, which had happened in history, as far as I know. So float has not that much precision, but it is faster, by the way. If you have calculations that can lack precision but need to be fast, you can go ahead and use float. But if you have scientific computations that need to be accurate, then you go ahead and use double, because it has more precision. And you can also see that 12.34 is not really possible here. The reason behind that is that we are using a 2-base system, and some numbers, some floating point numbers, cannot be represented in 2-base with the accuracy. So this is a whole nother topic, which is extremely out of our scope, but there's such a thing, and you should be aware of that. In float, you can see it kind of has 34,015. Here we have 33,99999 and 86 at the end. If you multiply them by 2, the difference in error should be less for the data type double. So hope that I did answer your question.
Yeah, I got it. Thank you.
You're welcome. Hızlıca Türkçe tekrar etmem gerekirse arkadaşlar şunu söylemem gerekiyor. Float dediğiniz şey küsuratlı bir sayı, evet. Ama küsuratının noktadan sonra, virgülden sonraki hane sayısı düşük. Haliyle burada sayıyı hassas bir şekilde tanımlayamıyorsunuz. Belli bir küsurata kadar doğru tanımlıyorsunuz. Fakat double'a geldiğiniz zaman bunun 2 katı hassasiyette olduğu için çok daha doğru bir temsil olacaktır veya çok daha hassas bir sayı tutabileceksiniz burada. Hane sayısını editör bana yardımcı oluyor. Visual Studio Code bana yardımcı oluyor, gösteriyor ve görüyorsunuz ki daha çok hane sayısı var. Bu sayıyı bu şekilde kullanıp 12.34'e yakınsamak var. Bu şekilde kullanıp yakınsamak var. Bir noktadan sonra özellikle de yüksek sayılarla çarpılacaksa bu küsuratlı şeyler, double'ın daha doğru çalıştığını göreceksiniz. Şimdi burada da şöyle bir durum var. C aslında performanslı kullanılabilen bir dil olduğu için eğer hassasiyeti hıza kurban edebiliyorsak, eğer vazgeçebiliyorsak, hızlı çalışmasını istiyoruz, çok da doğru olmasa da olur diyorsak eğer float kullanırız. Böylelikle hızlı işlem yapar. Çünkü kayan noktalı diye çevriliyor. Floating point birebir çevrilmiş Türkçesine, ama virgüllü küsuratlı sayılar hesabında bilgisayarların zorlandığını söylemek çok da yanlış olmaz. Çünkü 2 tabanında bu işlemleri yapmak gerekiyor ve hassasiyet kayboluyor. Apayrı bir konu, konumuzun dışında, ama float kullandığınız zaman çok hızlı çalışıyor. Ama hassasiyetten biraz kaybediyorsunuz. Genellikle grafik hesaplamalarda float kullanılmaya dikkat edilir. Çünkü görsel olarak insanın algısı belli bir yere kadar fark eder. Küsurattan sonraki bilmem kaçıncı haneyi. Ama diyelim ki NASA'dasınız. İşte uzay araştırmaları merkezinde küsuratlı bir sayıyı çok büyük sayılarla çarpıyorsunuz. Double kullanmanız, hatta double kullanmanız bile yetmeyebilir. Kendi veri tipinizi üretmeniz bile gerekebilir. Çünkü böyle bir şeyi 10 üzeri 9 ile 10 üzeri 20 ile çarptığınızda aradaki fark çok ciddi büyüyecektir double ile float arasında. Double'ı double float, yani 2 katı hassas float gibi düşünebilirsiniz. İsmi de oradan geliyor zaten. Alright, now I can give it some digits that it can use. It can use also precision. What I can do is I can also, if I want to print them alongside each other and want to put some space, for example, let's compile this. You can see I can have height equals that and then height equals that. It doesn't really matter. Because I didn't provide it 2 times, we did end up in height equals 0, something like that, which is not correct. Here we have the correct thing. So if you are using %f or %something, then you have to give it also a value. If you are missing a value, it just used 0 for it. But it didn't warn you that this was a problem. It just executed it because printf works in a way that it takes, it has a stack-based operation, which is complicated for now, which I'm going to skip for now. So if I want to have a little bit more space between these two strings, what I can do is I can just use \t, which is again another special meaning. So we can have \t, which means tab. The tab key on the keyboard is \t, and then we have also \n, which is new line or the enter key on your keyboard. So let's first of all look for this. You can see it has a space and then we have a tab. So you can space out stuff here. It becomes relevant for some cases, or you can use new line here. You can see now we have the output, new line, and start from here. So Printf, if you look up the documentation here, let's say Printf. So you can have Printf. This website is not bad. You can use it. So it returns ints, which we didn't really store anywhere. So we skip that. We can do that. You can just call something and don't handle the return. Here, if you use %c, it will be a character. D is decimal. There are more stuff to it, but I just skip them. There are also some scientific outputs if you use, for example, E. Let's use E and see the difference. You can see now it uses the exponent approach, 10 to the power of 1 times 1.234. So it's the scientific notation. There's also capital E, as far as I remember. It does the same, but has capital E for some reason. I don't really remember the difference here. What is it? Yeah, it just uses capital E. Sometimes C is weird. So why do we have this capability, but we cannot pass in through just the data type and it calculates? Well, yeah. Decimal floating points, a shorter approach, G. You can just experiment with them to see what the difference is. We can use octal numbers. I am going to show that in a minute. Unsigned stuff, I'm not going to go into detail. We have percentage, yeah. Let me see if there's anything else. So there are some capabilities. It says, for example, if you use dot number, it will use precision, how many values after the point you want to have. This does nothing, etc., etc. You get the idea. Sometimes they have also some interesting examples here. Sometimes it's too much crowded for you, so therefore we have our own code and notes. But if you want to learn more about it, you can just check out the documentation at that point. Now, yeah, what else? Well, we have seen that there's a function called printf. Of course, you have to experiment with printf in order to be in order to get comfortable with it. But this is printf. What do we have now? We have also scanf. So let's maybe do that.
Hocam benim bir sorum vardı.
Hı hı.
%8.8 niye kullandık?
Maksimum 8 saniye kadar gösteriyor bunu. Baş kısmını. Yani işte şu kısmı. Ama ihtiyacı yoksa o kadar da kullanmadı şu an gördüğün gibi. Noktadan sonra 8 tane kullan dediğimizde şuradaki 8 tane şeyi kullandı o yüzden. Kullandığımız için de bilimsel gösterimi kullandı. Bilimsel olmayan gösterimde şurada kaç hane sonrasında göstereceğini söylemiş olduk. Hiç onu kullanmadan da şöyle yapabiliriz. .8 deriz. Önünde ne kadar hane olduğu önemli değil. Önemli olan noktadan sonra bana 8 hane göster diyebiliriz. O da bu şekilde çalışmış oldu.
Hep 8 haneyi göstermesi gerekiyor mu?
Efendim?
Hep 8 yazmamız gerekiyor mu?
Yok 8 değil. Ve 4 de olur mesela. 4 tane hane gösterir.
Niye görebiliriz?
Şöyle yapayım. Bak bu defa da 4 tane gösterdi. Burada da 4 tane gösterdi. Yani buradaki sayı neyse o kadar hane. İstersen 20 de 20 tane hane göstersin.
Anladım. Süreye göre yani.
Tabii o sayı noktadan sonra kaç hane görmek istediğimizi söylüyor. hiçbir şey yazmadan da hiçbir şey yazmadan da F diyebiliriz. O zaman şöyle olur. Kendisi seçer. Ama biz onu kontrol etmek istiyorsak noktadan sonra 5 hane istiyorum diyebiliyoruz. Böyle yapmış oluyor. Hatta şunu da F'e çevireyim. Aradaki farkı görelim.
Anladım, tamam. Teşekkür
O
ederim.
kendisi mesela 6 kullanıyormuş. Biz 5 olmasını kısıtlayabiliriz.
Anladım.
So after the point, we actually specify specific amount of digits here, but you don't have to do it. You can just provide F if it's a float or double number. It will just directly use the default values or properties that is set up already. But you can explicitly specify how many digits you want to see. This becomes relevant, for example, for big numbers. If we have something like this, actually, we don't use A. If you have such a large number, and if this is, for example, kilos, at some point, I don't want to see this many digits here. So I don't really want to see what the digits are. I want to be I want to see, for example, just one digit, because it is a huge number and the precision loses its importance for me. Then I might go ahead and use 1. Or if it's a small number, like something like this, then you can see using just 1 digit is not relevant, because I cannot see even the number itself. It's just 0. But I'm interested in these digits, so therefore I should give it a number like, for example, 6. This would be, if it's like micrometer, then 0.6 would make sense. Therefore, it depends on the usage or on the data type here. I want to format it, and I can do it. I can use tab, I can use new line, I can use lots of stuff, but there are important characters here. Percentage is one of them. If it's an int, float, double, char, I have to use these letters to indicate that the data type is a specific data type. And then I can use this approach here in order to control how many digits there are. So that's basically it for printf. Any other questions? All right, then. Now, let me show you Scanf. That would be the third part. And then we will have something called the Ascii table. We'll print out the Ascii table and conclude the lesson for today. Now, Scanf is basically the same, but here printf prints out to the console. So Scanf would do the inverse. So it will just take info from the terminal. So let's actually use height here, define a variable, a piece of memory that will hold floating point numbers in it. Now I want to enter the height here. So let me just get rid of that. So just put in the value height and then display it back with the default stuff. So I have a variable called height, type float. I want to force the user to input their height or a certain float number, and I want to show it back to them. So this is basically a standard input-output. We have input with Scanf. This is output, so we have basically input and output. So let's see. By the way, this should throw an error. We'll see why. So it waits for me to input a number, but the program crashes. Yeah, this is actually the difficulty of C, because you cannot provide any variable to it and expect C to understand it. You have to, since you're communicating with a machine, basically, you have to tell everything explicitly in order to be able to communicate with the machine, in order to be able to tell the machine what you want to do. So what I mean by that is the following. Since this is a value, since Scanf needs a certain piece of memory address to it, it's not able to calculate where to put in the number 23 in this case. So let's think about what would be a global example? Let's say we have DHS or for native ones, you think about PTT, for the global ones, DHS, the post office. And we are sending mail to a certain home. So home 1, let's have home 2, home 3, etc. It goes on like that. Of course, this should be a specific address, this district, this street, etc. But you get the idea here. Now, how would DHS or PTT know where to send the mail? It would need an address. And at each home, they would be assigned a certain address here. So instead of home, let's say variable. And all variables will have addresses. In order to be able to extract the address of, for example, variable 1, we will use, again, another special character. And it would look like this. So an ampersand helps us to extract the address. Because once the mail arrives at variable 1, so variable 1 equals, let's say, 20, and the mail was 20, the number 20. If I want to have the value, I use the variable name. If I want to get the address where the value is stored, I need to use &var in order to get the address. Because this, all these variables live in a memory, which looks like this. 2, 3, 4, 5, 6, 7, 8. We have a certain memory like this. This is the RAM. And if I define a certain variable, for example, let's use char var1. If I define these, then since it's sequential, this would be var1, and this would be var2, this would be var3, and this would be var4. Now the address of var1 would be just 0, and the address of var2 would be 1, this would be 2, and this would be 3. Now, if I call var1 on its own, I would get, let's put in some values, for example, 1. Let's make this here, and maybe 1, 1 here. So this is the data. This is the address of that variable, and this is the variable name. So var1 is equal to 1, looks like this. And this is equal to 3, this is equal to 0, and var4 is equal to 2. So the memory would look like this, and their address will be 0, 1, 2, 3. Their names would be var1, 1, 2, var3, and var4, and the memory would look like this. If I want to put in this value 20 into variable 1, what I have to do is I have to use &var1 and provide it to Scanf. So it goes to the corresponding address. In our case, 0. This would be translated into 0. And that part, 0, would be equal to 20, or whatever the mail is, or the number is. So using ampersand is quite important, and it is converting it into an address. And that's all you need to know for now. Because you're looking for a Scanf and you want to put in a certain value to a certain address, what you have to do is you have to provide an ampersand. So let's try that out. It's a bit complicated, but stick with it. For now, you will get the way of thinking as time progresses, hopefully. So let's put in 23. Height is equal to 23. So this is the value, this is the address. So Scanf looks for a certain address. Now I can do something interesting. Hope that I can do it now. And the address is D. I guess I can do something like that. and then the value is this. So let's try to put in height, the address of height, ampersand, not percentage, of course. So I'm providing it a certain address to it, and this should be %d. I hope that it is an integer. We'll see, or I can convert it into integer, hopefully. And I also want to see what the value is. So let's run it. 23. The address is a certain number, and the value is 23. You can see that ampersand height is not a float anymore. It is basically an integer, a 32-bit integer. And that's basically the address of that. So let me copy it and paste it here. If I run it again, 34, I'm still using the same address here, 6422300. So let's define another variable, height2, do it again, and let's see what happens. So 23, 32, still the same address. What about height2? Now the address changed. Let's see what both the addresses are. Of course, a new line would be a good thing here. Let's add that too. 23, 32. There we go. The first one's address is 6422300, and the value is 23. The next one's address seems to be the same, but 296 now. And it would basically go on like that. Let's see. Yeah, I didn't define it. So 23, 24, 25. There we go. You can see as an integer, it kind of changes. It subtracts 4, seems like it. And the reason for that is maybe I might use an unsigned decimal. These are just stuff that we should not be concerned with. It still didn't change. Maybe it should be hexadecimal, etc. But it's not really that relevant for now, because that's not the point. Yeah, it is 61 FF1C, and then it's 18, it's 14. The addresses might change on your computer because when you invoke your code or when you run your code, you are assigned a certain memory space, and that memory space address would change. But the thing that I want to talk about here is that there's something called an address, which can be used with Scanf to show where to store the value that will be inputted. And the ampersand helps us in determining the address of a certain variable. Other than that, you will use height if you want to printf, not ampersand height, but if you're interested in the address, you can just do it like this. But enough for this stuff here. Let's get rid of it. The basic code is this: float height, scanf, stored in the address of height, not height variable, because that's not possible. And then show the value height, and that's basically it. 23, height equals 23. So this is basically hello world, printf, scanf, and I want to talk about the Ascii table and conclude the day. Now, the Ascii table is an important table that we will generate in a moment, but you can just Google it. You can find it on Google. Just type in Ascii table, and you'll be seeing lots of tables here. One of them is this. Hope that we can open it up. Where is it?
Scanf'i Türkçe'yle kısaca anlatabilir misiniz?
Ascii tablosunu mu öncekini mi? ASCII tablosunu mu öncekini mi Türkçe anlatayım?
Scanf son parçası.
Tamam. Şimdi şöyle. Az önce aslında örneğini vermeye çalıştım. İşte PTT'yi düşünün. PTT'nin bir mail gönderdiğini düşünün veya bir posta gönderdiğini düşünün. Bu postayı bir adrese teslim edecek. Şimdi Scanf de böyle çalışıyor. Scanf'in ihtiyacı olan şey öncelikle nasıl bir veri gireceğimiz. Bakın burada %f ile aynı printf'te olduğu gibi Scanf ve printf'te bu sürekli olan bir şey. Format dediği kısım bu aslında. Printf'in veya Scanf'in üstünde durduğunuzda alt tire format yazıyor bakın sonuna doğru turuncu bir renkle. Format dediği şey tam olarak bu. Çift tırnak arasında belirttiğiniz şey bir format ve formatın tablosu burada. Eğer int kullanıyorsanız D kullanırsınız. F kullanıyorsanız double veya float'tan bahsediyorsunuz. C char, S de string. Bu formatı belirttiğiniz zaman nasıl bir veri tipinin geleceğini biliyor Scanf artık. Nereye koyacağını ise adresten buluyor. Yani hide diyerek ve şu end işaretini koymayarak bunu çalıştıramazsınız. Çünkü siz aslında hide derken değerden bahsediyorsunuz. Yani 20'den bahsediyorsunuz. 20'ye gidip bunu koyamaz. Ama adresi çevirdiğinizde az önce gördünüz işte 66 1F C 22 gibi bir şeyler gördünüz. O aslında adresiniz gibi. Yani adresi burada vermeniz lazım ki değeri, bu veri tipini o adrese yerleştirsin. İlerleyen zamanda zaten pointerlar konusu gelecek ve orada zaten bol bol bundan bahsedeceğiz ama Scanf zaten başta kullanacağımız bir şey olacağı için Scanf kısmını bu şekilde öğrenmemiz gerekiyor. Adrese çevirmek için bir end işareti kullanılır. Bu end işaretiyle height değişkeninin adresine bu değeri koyar. Böylelikle aslında height eşittir ne gelecekse o olacaktır. Yani bu satır height eşittir 23'ü yapabilmek için gerekiyor. Ama height'tan ziyade height'ın adresi ve gelecek olan veri tipi. Tabii bunlar uyumlu da olmalı. Yani buraya D yazı float'a eşitlerseniz çalışır ama tersini beklerseniz olmaz. Yani buradan D gelsin, float'a koyayım dediğinizde bu bunu kapsayabiliyor. Ama D olan bir şeye float girerseniz muhtemelen küsuratı kaybedersiniz. Önemli değil. Önemli olan veri tipiyle adresi vermeniz gerekiyor Scanf'e. Printf öyle değil. Printf değeri alıyor ve formatı alıyor ve şunu oluşturuyor. Gördüğünüz gibi height 23'ü bu şekilde oluşturmuş olduk. Sadece dediğim gibi aradaki önemli farklardan bir tanesi Scanf'te bir adrese ihtiyacınız var ki adrese teslim değeri gönderin. Adres vermezseniz çalışmıyor. Tekrar da gösterebilirim.
Hocam yani tanımlıyor gibi bir şey mi oluyoruz orada height'ı Scanf'te?
Aslında şu aşağıdaki adresi vermiş oluyoruz. Aslında Scanf'den önce zaten bunun tanımlı olması gerekiyor. Yani height diye bir şey olmazsa height'ın adresi de olmaz. Nereye koyacak?
Bu şekilde yapamıyoruz yani. Önce
Bu şekilde
height
yapamıyoruz.
tanımlıyor.
Önce bir değişkeni tanımlamamız lazım. Bu gidip burada bir yer ayırtmış olacak. Yani bir adresin oluşması lazım. Adres oluştuktan sonra da end işaretini kullanarak o değişken ismine karşılık memory'deki yeri söylüyoruz aslında.
Bu bize ne sağlıyor peki Scanf yapmamız?
Scanf yaptığımızda bu height'in değeri 23 oluyor. Şöyle yapabiliriz bunu da görmek için. Height'in değeri neydi? Scanf'ten sonra ne olduğuya bakabiliriz. Height'in değeri 0. Ben ne girersem o oldu şimdi. Etkileşim sağlıyor. Yani dışarıdan ben veri girebiliyorum. Yarın iki sayıyı toplasın veya bir sayının sinüsünü hesaplasın dediğimde kullanıcıdan hangi sayının sinüsünü veya toplamını hesaplaması gerektiğini Scanf ile çekeceğim. Scanf kullanıcıdan bilgi girmesini sağlayan kısım. Printf ise kullanıcıya geri bilgi gösteren kısım. Biz de terminalde çalıştığımız için biraz enteresan geliyor. Günümüzde artık işte web sayfalarında, edit field'larda bilmem nelerde text box'ların içine yazdığımız için butona bastığımız için veya görselde bir şey gördüğümüz için bu biraz kopuk gelebilir size. Ama aslında terminalden kullandığımız zaman, bu şekilde CMD'den kullandığımız zaman bilgi girmek için bunu yapmak durumundayız. Bu biraz da ilkel kaldığı için günümüz bilgisayar yazılımlarına tabii ki bir kopukluk olabilir. Ama ileride dosyalara yaz oku dediğimizde de aynı şey. Yine Scanf, yine Printf kullanacağız. Ama bu defa terminale değil dosyaya yazacağız, dosyadan okuyacağız.
Hocam
O zaman işler değişir.
printlemesek direkt Scanf sadece tanımlıyor mu değeri? Yani ne yapıyoruz? Yani direkt
Scanf içini dolduruyor. Şimdi şöyle yaparsam, hiç printf'lemezsem sayıyı gireceğim gördüğün gibi ve hiçbir şey olmayacak.
Anladım. Tamam.
Şöyle bir şey de mümkün mesela. Height'ın işte 2 katını da hesaplayabilirim herhangi bir sebepten. Ama bunu da görmeyeceğim.
Hmm.
Çünkü kullanıcıya çıktı vermiyoruz. Bir yerde printf yoksa hiçbir şey görmeyeceğiz.
Ha, bu bize input vermemizi sağlıyor yani. Kullanıcıya input vermesini sağlıyor sistem.
Evet, kullanıcının bunun değerini değiştirmesini sağlıyor.
Hı hı,
Bu değişkeni
tamam.
ben tanımladım. Bununla ileride bir şeyler yapacağım. Ama şu arada da kullanıcı değerini girecek. Ama printf'te koymalıyım ki o değeri en son görebileyim.
Görebilirim.
Mesela 2 çarpı height diyeceğim. Tabii bu örnek yaptıkça daha çok oturacak. Ben şu an şey yapıyorum, anlatıyorum. Ama örnekle daha çok oturacak. Mesela 23 girmesini sağladım. Ne yaptım? Değişkenini tanımladım. Böyle bir değişkenim olacak. Bu değişkeni kullanıcı dolduracak. Kullanıcı doldurduktan sonra ben kullanıcıya 2 katını vereceğim. Herhangi bir sebepten, neyse o sebep bilmiyorum şu an. Ve konu kapanacak return 0.
Anladım hocam. Sağ olun.
Rica ederim. Now, let's generate the Ascii table and let's see why it is relevant or what it really means. Now, if you Google the Ascii table, you'll find the Ascii table easily available here. And actually, the Ascii table it stands for American Standard something something. I don't really remember it, but actually, this is a way of defining the keyboard. For example, all the characters of the keyboard are given in this table, and this table is arranged so that this is a standard. And if you use, for example, the decimal value, let's pick one here. For example, 55. This stands for the 7 key on your keyboard. So this is basically a standard, and you can use this in order to manipulate text or even define a text in the programming language C, for example. This Ascii table is used widely during the programming languages and their courses, of course, but you can see that there are some special characters missing, and it goes only up to 127. So these are basically the English characters, the American keyboard, and all the characters are placed on that. But if you have, for example, a Turkish keyboard, in our case for most of us, then these are the keys, and then you will have some extended keys, which are not available in the Ascii table. Therefore, during our programming sessions, we will not use Turkish characters. For example, I'll not use this character here, or this one, or this one, or this one, or this one, because it's not on the Ascii table, and we don't want to deal with all the different character types and stuff. In web pages or in some files in Notepad++, as far as I remember, there are these character encodings. Here, for example, and there is this encoding somewhere here. UTF-8, for example, here is the encoding. And you can change it to Ascii, which stands for basically ASCII characters. Now, if I put in the Turkish characters, which you cannot see, but I'm trying to put them in, they will be converted into their equivalent Ascii table characters because they are not available here. You can see Ascii. But if I change the coding to UTF-8, then you can see I messed it up, but I can now type in the Turkish characters now. So it's important to know the difference here. Not really that relevant for us because this is an English course and we will not use Turkish characters. So that's one way of solving stuff. But if you want to do something professional, then you have to take into account that there's such a thing and you have to work with UTF-8 strings, etc. But that's not our concern for this course. So we will not use Turkish characters, in short. But we will print or try to print the Ascii table now. And we can do it by just using printf on its own. And why there is an Ascii table or what the values correspond to will be hopefully gain meaning in a few minutes. So I want to printf a data type, let's say decimal. Let's give it a number, let's say 10. And I want to print this out via a decimal. So let's do this. I compiled it, and for some reason, we have a different value here. So yeah. Printf. Oh, yeah, of course. Now, can you spot the error? Did anyone spot the error? Because I did. First of all, why is it working? Second of all, what the hell is this number? Hatayı gören oldu mu? 1, neden çalışıyor? 2, ne bu sayı?
Hocam specifier verdik ama onun için ilgili alakalı değeri vermedik.
Formatı
O da
söylemedik.
rastgele,
Aynen
rastgele
öyle.
bir değer döndürdü.
Aynen öyle. Formatı söylemedik. Dolayısıyla o da o anda bir yerde bulunan, RAM'de bulunan bir şeyi bize gösterdi. Biz hangi değişkenin değerini göstereceğimizi söylemedik. We didn't specify which variable we will use in order to convert it into this format. So it will print out a decimal, but it is missing the variable itself. So if I provide now the variable itself, you can see it works now. So be careful. Sometimes programming errors, coding errors are syntax errors. Sometimes you mess up the semicolon and you cannot compile it, as you can see here. And it will warn you. It will say you have used printf. There's missing something. Maybe it's a comma, maybe it's a semicolon, but something is missing. Therefore, it says error expected comma or semicolon before printf or after or whatever. But in some cases, this is called a syntax error because you messed up the language specifics here. But sometimes these types of errors are the most dangerous ones because the code does not crash, it works, but it behaves strangely. So this is the most dangerous error. So be careful. C is a dangerous language. You can mess up stuff, but if it's a logical error, like in this case, if you have missed something, your code might be working, but it behaves strangely or not as you expected. So yeah, be aware of that. It is possible to have a running code, but running faultily. So I have a decimal 10. I can print it out like 10, but there are some different types, as you can see here, and one of them is D. So what happens if I, for example, convert it into C and provide again the decimal here? So I'm providing decimal values, but one of the formats is %d, which means integer, but one of them is %c, which stands for character. So let's see what happens. And well, we didn't see it that much, but let's pick another number, like 100, for example. Run it again. Now we can see that the decimal number 100 corresponds to the character D. Let's go to the Ascii table, search for 100. It is here, and you can see it is converted into D. So if we define the decimal 100, if we convert it into a character, we will get D. So this is basically already converting decimals into characters using the Ascii table. So I can already define the decimal, print it out in 2 different ways, and it will generate the Ascii table. But there are 2 more columns in our Ascii table. One of them is hexadecimal and octal. So we can do that too by using %x and %o. So if we stick with the same order here, decimal, hex, and octal, and maybe we should place some tabs here in order to space them out, and then maybe a new line. But since I have 1, 2, 3, 4 different formats, I should also have 4 different values. So each of them correspond to the formats given here. So %d decimal, %x, again the same decimal, %o this decimal, and %c decimal. So if we compile it, we can see 100, 64, 144, and D. This is the line here. 100, 64, 144, and D. This is the same line here. So by repeating this, so let's increase decimal by 1. So do you know how to increase the value of decimal? One way is just putting it like this. Decimal equals 101 means that I'm assigning the variable decimal to 101. But I want to increase decimal by 1. How can I do this? Any ideas? Şimdi desimal eşittir 101 diyerek ben bunu artırabilirim ama bir artırmayı nasıl yapabilirim? Kendisi hesaplasın. Ben kendim eklemeyeyim de C eklesin. 1 eklesin. Çünkü bir sonraki satırı yazdır. Var mı fikri olan? Well, you can increase decimal by 1 like this. But if I want to do this, I have to copy paste this into all the decimals here. So decimal plus 1, and then so decimal plus 1, decimal plus 1, decimal plus 1. So this is possible. So 164, 144D, and the next character is E, and those are the numbers. But
Can
yeah,
we add 1?
again,
Can we write add 1?
if we do it like this, do you mean this one here or something else?
No, I didn't mean that. As operation, add 1.
So like this. Is this what you mean?
No, I mean that we can write add 1.
Add 1. And how do I write that? Because
know.
there's this addition, there's 1.
As
So I'm
operation,
kind of trying to add 1. The solution was to add it here. So it would just have 100 here instead of this. This would be the result, and it would be calculated as 101. So that this would work. But since I'm already using this variable on its own, maybe I should add 1 to the decimal here, the variable itself, but the result should be assigned to itself again. So this is a weird way of doing it, but it works. Let me show you that it works. First of all, it works. But what it does is it does this. It takes the previous value, pastes it in here, does the calculation, and once it did the calculation, it looks like this. Assign decimal to 101. So therefore, we will use decimal equals decimal plus 1. But if you see such a statement, what you have to do is you have to start from the right-hand side. Otherwise, it doesn't have it loses its meaning, because decimal is not equal to decimal plus 1. It doesn't make sense. But if you start from the right-hand side, the previous value of decimal, or the current value of dec, is 100. So 100 plus 1 is an operation. Carry it out, it would make 101. Then this looks like dec equals 101. So I'm assigning 101, the value, the calculated value, to the variable. Eğer ben işte dec eşittir 100 değişkenini kullanarak böyle bir ifade yazarsam sağ taraftan başlamam gerekiyor anlamaya. Yani şu anki değeri ne bunun? 100. 100 artı 1 nedir? Bu işlemi yapalım. 101. Dolayısıyla yeni değeri veya bu değişkene 101 atamış oluyor. Now I can repeat this over and over again, because each time I'm increasing the value by 1, I'm using the next decimal, print everything out, increase it by 1, print everything out, etc., etc. This would give me a portion of the Ascii table, starting by 100 and stopping by 106, for example. Let's copy paste a couple more times. 8, 9, 10, I guess 10 values now. Exactly. So I can now print a portion of the Ascii table, and it gives me the characters and the decimal, the hexa, and the octa values also. So you can pick any other starting point. Let's start with 0, for example. And it would give me the first 10 rows. And you can see it prints out some weird characters. And the reason for that is that these are special characters and they have special meaning. Now, if we, for example, start with 10, the next 10 characters look like this. And then the next 10 characters look like this. Up and down arrow keys and stuff. So we can see there's an ampersand, percentage, hash sign, etc. exclamation. So it is kind of interesting to generate it on your own. As you can see, it starts with the numbers, and as it goes up, it will just show you the remaining characters. And 150 is too much. If you start with 100, you will see that it goes on with the alphabet. So actually, there's a shorter version of the variable equals variable plus 1, and it is used like this here. So an increment operator, we have an operator that is called the increment operator, which is called plus plus. And this plus plus means that I will increment the value of this variable by 1. And that's it. So you can just get rid of these here. Let me just get rid of them. You can just use plus plus and it will give you the same. Let's see. There we go. It still works. It is the same, but it's shorter and you can use it. There's also the decrement operator. You can also decrement it. We'll see. So it is 100. It should decrement it. Here we go. It did it here. And then it incremented again. So it is also possible. So we can increment and decrement also here. But it's not really that important. There's also a version where we can do the following: plus equals 1. So now you can also give the amount of increment that you want to give. For example, in this case, it's the same, but so it's the same here. Let me just, by the way, get rid of stuff here. So 100 printf, increment printed like this. So we have a smaller table, but what we can do is we can change the amount of increment. So increment it by 2, 100, 102, 104, 106, etc. So these are things that we will get used to by time, but the actual thing is we can use plus plus, or we can just use decimal equals decimal plus 1, whichever you like. It's just the same. So let's talk about the meaning and conclude our lesson today. So what does it mean to have an Ascii table like this? So let's go back to the memory example here. And each of these 6 zeros and ones, 8 digits of 0 and 1, are actually correspond actually to a character. So if I would have a certain character like D, the value that will be stored in memory would correspond to 100. But of course, it should be the binary version of that. That should correspond to 100. So here we would store the value 100 instead of storing the character D, because it's not possible to store anything other than ones and zeros in our RAM on our computers, because yeah, the computer knows only ones and zeros. So we will store the value, the binary value of 100 in memory. So if we have a character, for example, D and E and F, if this is the string that we are interested in, then the memory would look like this. There would be 100. Here we would have 101. And then 102, and that's it. This would be then 0. And where did I conclude this? Well, the character colon is this one here, and the decimal colon is this one here. So you can convert it into a 2-base binary number, put it in here, or you can also put in the hexa value here. It doesn't matter. You would have this memory here. So it is important to know that actually you're storing an int value of 100, as you can see, an int value of 101, int value of 102. The editor, the Intellisense here, helps me out and shows me the decimal values of these characters. So this is a shortcut of defining basically character equals 100. So it's basically the same, but it makes more sense to use the single quotes and characters because we as human beings cannot understand what 100 means. If we have an Ascii table, we can convert it, but using it as single quotes rather than using the decimal values or hexa values for them makes more sense. So if you define a certain character, you should know that behind the scenes, this is actually a number of just 1 byte, 8 bits, and it is converted via the Ascii table itself. And we have generated the Ascii table, so you can just play around with it and see what it really does. In the upcoming weeks, we will learn some loops, some decision blocks. Once we have done that, we can just create or recreate the whole Ascii table. Yeah, then you can just toy around a little bit more. Let me explain in Turkish too. Eğer biz D, E, F karakterlerinden oluşan 3 tane değişken tanımlarsak, o zaman aslında memory ya da hafıza bu şekilde gözükecektir. Tırnak içinde bizim söylediğimiz işte karakterler veya klavyemizde mevcut olan karakterler bilgisayarda memory'de tabii ki sayı olarak 1 ve 0'lar olarak tutulacaktır. Bu 1 ve 0'ları binary yani ikili gösterimleriyle 8 bit olarak yüzü çevirirseniz elde edersiniz ve bu şekilde burada 8 tane 1 0 halinde gösterilecektir. Arka planda hafızada ya da memory'de bu sayıların 100, 101, 102 işte ne yazdıysanız hangi karakterse Ascii tablosundan onu sayıya çevirerek onların tutulduğunu görebilirsiniz. Bunu bilmek önemli çünkü bunu eşittir 100 demek. Sonra da bunu karakter olarak ekrana basmak çok biz insanların yapacağı bir şey değil. Çünkü 100 ne demek? Aslında D harfinden bahsediyoruz. Dolayısıyla tek tırnakla D harfini koymak 100 rakamın 100 sayısından daha anlamlı olacaktır ama arka planda zaten editörün gösterdiği gibi C bunu tek tırnak D yazdığınız zaman Ascii tablosundan gidip desimal karşılığını alıp onu tutacaktır. Dolayısıyla bunu bilmek tabii ki önemli. İlerleyen haftalarda if ve for gibi döngüsel ve karar yapılarını gördüğümüz zaman tüm Ascii tablosunu oluşturabileceğiz. O zaman tekrar bunu gelip kullanırız. Actually, this will conclude our lesson for today. And if you didn't follow along, I have already created a answer sheet for it. I have I have included different types of lines of code, but you can just experiment with them. You can just copy and paste them and try to run them, compile them. I highly recommend you to set up your compiler and your work environment in order to follow along in the upcoming weeks, because this week I talked too much. I will hopefully transition into teach you some stuff and then wait you to code it, and then you will ask me stuff and I will answer it, etc., etc. But you can see I will upload this PDF and you can go ahead and use this code. It might be a little bit different than the ones in the video, but the theme remains the same. You can see we have again the Ascii table code here. I will provide you this PDF so you can just use those codes and experiment with that.